So number 5 is asking define complex number in standard form. So complex numbers in standard form. So what we can do here is they actually give you a really nice solution here, and I'm going to explain the solution as well. So it says a number of the form z equals a plus ib is known as a complex number. So z, which is the common kind of which is basically any number. It could be real or imaginary here, or complex. Z here equals a plus ib. And and how we break this down is we have z here, which is basically our like any number here. A here is going to be the real part of our number. So a here is the real part. So anything that's a real number. And then b here is also our real part. And I here represents our imaginary number. So that's going to be our complex part. So I here is defined as the square root of -1. And this here is universal because we're working out in the complex plane. If I take the square root of -1 here, I'm going to get an imaginary number. So this here is I. So a and b are real numbers. Sorry, this is are real numbers. But a here is the real part, and this here is the complex part. But a and b are both real numbers. So sorry for the confusion there. So for example, if I were to write, let's say z here equals 3 minus 2i. Well, I know that this here is a complex number in standard form. And I can break this down into our real parts, right? So if I were to plot this, I can say that this guy here is this, or this guy here would be A. This guy here would be B. So I have, this number would be, if I were to write it in a coordinate form, this one would be 3 and -2 here. And if I were to plot this out in a real and imaginary plane, so this one would be in the real plane, this here would be the imaginary plane. I have 3 here, which is going to be, let's say 1, 2, and 3, and -2, so 1 and 2. So this here is -2, so I would have something like this, approximately. So this would, it would be a vector going from the 3 right to the real plane, and then 2 down in the imaginary plane. So this would be considered, so z minus 3, or z equals 3 minus 2i, here would be considered a standard form of a complex number. So it's basically, in summary, you have z here, which is going to equal a real part plus an imaginary part. A and b are real numbers, and I here is the imaginary part. And we can graph this in terms of real and in the real and the imaginary plane. But this here is the standard form of a complex number. So the solution here is correct.